Hello, welcome to another section of Math Math. Let's look at this question. So, integral x cubed divided by square root of x squared plus 9 dx. So, integral x cubed divided by square root of x squared plus 9 dx. Before we start, let's write our solution first. Let's repeat this one. X cubed divided by square root of x squared plus 9. Here, what we are going to do is that we are going to do substitution. But are we going to let, let's say, u or m be equal to this or this one? Well, here we are going to let u be equal to what is in the square root, that is x squared plus 9. We are going to let u be equal to x squared plus 9. Provided this x cubed could have been something like x, could have just, we could have just, after letting this x squared be equal to, after letting u be equal to x squared plus 9, could have just differentiate and then cancel out whatever we get after the differentiation with this one, and then we just integrate and then write down our answer. But here this one is what, x cubed. So even after differentiating this, I don't think whatever we are going to get as differentiation answer will be able to take away the whole of this. It will take some and to be left with what, some. And when some is left, how are we going to do that, or how are you going to handle that problem? Well, you don't worry. You are just going to find out everything. I mean, what happens sometimes when you differentiate and part of the what you are eliminating remains. If part of them remains, how you handle that problem or how you deal with it. Okay, so like I said, we are going to let u be equal to x squared plus 9. U be equal to x squared plus 9. We are going to differentiate. Now when you differentiate, u is going to give us du. When you differentiate x squared plus 9, you are going to get 2x dx. 2x dx. That is how I got the 2x dx. Now when you differentiate this one is a constant. Anytime you differentiate constant, you get 0. So we just ignore this one because at the end of the day it's going to give us 0, and whatever we get after differentiating this, when we add the 0 to it, it is going to get the same answer. So put it in your mind that when you differentiate any constant, and I mean any number at all, it is going to get 0. It is going to get 0. Now, x squared, when you differentiate x squared, it simply means that to differentiate x squared simply means that you are to multiply this power by the base, which is what? X. And then you decrease the power by 1. Decrease the power by 1. Now, 2 times this one will give us 2x. And then x, 2 minus 1 will give us what? 1. So the answer to this one is going to give us 2x raised to the power 1. And any number, any variable raised to the power 1 is the same thing as what? That number or that variable. Okay, so when you differentiate this one, we are going to get du is equal to 2x dx. Yeah, so du is equal to 2x dx. Well, we need to find dx. We need to find dx because we are moving from the x world into the u world. Okay, now this is not a double integral where you have to, deal with two different variables at the same time. This one is just a single integral, so we don't have to bother ourselves, including two different variables at the same time. When we do that, we find ourselves very wanting, and it's going to be very difficult for us to solve since it's not a double integral. So what we are going to do is just move everything into the u world. If you are dealing with x, everything should be in the x world, and if you are dealing with u, everything should be in what? U world. Okay, now we know that du is equal to 2x dx. What is going to replace dx? Remember, we have made substitution, so what is going to replace dx? Here we are going to divide both sides by 2x. Divide this one by 2x, and then we also divide this one by what? 2x. Now when you divide this one by 2x, we are going to get 2x divided by x, and this one also du divided by 2x. Now this one and this one will cancel out, and we left with dx. So we are going to get dx is equal to 1 over 2x du. Good. Now we know what is going to replace dx, that is 1 over 2x du. Remember, don't worry about this s because we are going to do cancellation at the end of the day. Okay, and I want to show you everything. I just don't want to, omit some of the calculations that we'll be doing. I just want to include everything. I just want to show you everything, how everything came by. Okay, so that is why I've maintained this x here. Though we are moving from the u world, moving from the s world into the u world, but we'll be seeing x in the u world. But that does not mean we are going to integrate them or work on it at the same time. I am maintaining that one there because I want to show you the cancellation that is involved in this workings. Okay, I just want to show you the cancellation aspect. That is why I'm maintaining the x, and you could realize that after the cancellation, you see that everything will be in what? One word. That is what? The u word. Okay, and also remember, initially it was u is equal to x squared plus 9. U is equal to x squared plus 9. But remember I said when you make substitution, it means you are moving from one word to another. And to solve integral question, all of them has to get what? has to be in what? One word. That is either x or either u or either whatever variable that you are working on. By the time you make substitution, means you are moving from one word to another. U was equal to x squared plus 9. But because we are moving from one word to another, and after our cancellation, we are going to get some of the S word component or S word, let's say element remains still in the what U word. We have to know what is going to replace that leftover. I mean, after the substitution or after the cancellation, whatever that is left at the end of the day, if you want that one also to be in the U word, what is going to replace it? Okay, so when we do the cancellation, you will see that we are going to get x squared at the end of the day. That one is going to be the what? The numerator. And we can't, like as I said earlier on, that we can't deal with two variables at the same time in a single integral. It's not a double integral. So to make the work easier, everything has to be in what? One word. So when x squared remains, how are we going to take that one into the U word, or how are you going to deal with it? We also have to find something that will replace it. Okay, and so to do that, we know that U is equal to x squared plus 9. X squared plus 9. So what is x squared, or what is x? U is equal to x squared plus 9. We can make x squared the subject. And when you make x squared the subject, you are going to get x squared is equal to u minus 9. That is, you just bring the positive to the other side of the equation. Though it's positive there, but the moment it crosses the equal sign, it becomes what? Negative. So when you make x squared the subject from u is equal to x squared plus 9, you're going to get x squared is equal to u minus 9. This means that after the cancellation, whatever that remains, or whatever that remains, this is going to replace whatever that remains after the cancellation, meaning that after the cancellation, wherever we see this x squared, we are going to replace it with what? U minus 9. Now that we know everything, let's put all of them into the integrals and let's find out what happened. Please don't be confused. I said that everything has to be in what? The U word. Everything has to be in the U word. But here we are seeing some x here. Remember I said I want to show you. Remember I said I want to show you everything, including the cancellation aspect. So here you could see that x cubed and this one matches. This one can cancel out with this one. It will be left with what? X squared, and it will be left with x cubed divided by what? X will give us what? X squared. And that is the x squared here. Now after the cancellation, you can see that whatever remains, there is nothing that we can do. And so far as that one remains, we cannot integrate it unless we find. So even if we can integrate it, it won't be all that easy for us. So we have to find something that will replace the leftover. Okay, so that we can continue our integration. Okay, so this x cubed divided by x will give us x squared. So that x squared is going to be replaced by what? See, x squared is equal to u minus 9. So here, this will decrease the power of this one by 1. It will be left with what? X squared. Yeah, you see, after the cancellation, we've gotten what? X squared. And here, there is nothing that we could do, or there is nothing that we can do to, take away this what? X squared. The only way that we can deal with this x squared is to what? Find what is going to replace it. And that is the way of what? Handle it. So anytime you are dealing with integrals or you are integrating a particular problem and you make substitution, and after the cancellation you realize that some of I mean some of the other variables that you substituted for has what? Remain. This is how you solve it. Whatever that remains, you find a means to replace it with the word that you are moving in. I mean, with the word that you are what moving in, meaning that is the u word or whatever word that you be what making, or whatever that your substitution is what taking you into. Okay, if provided if the variable I choose is p, we have moved from s word to p word. Okay, I always use the word so that um you know that with p word everything that we are going to see is what about p, and you see that you will not think of anything that relates to what? X. That is why sometimes I prefer using the p word or u word or s word. The moment I say this word, you see that everything is completely in what? In that state. Okay, so x squared over square root of u du. You see, we can't work on it unless we find something to replace this. And here, x squared is equal to u minus 9. So wherever we see this one, we are going to replace, you're going to put this one what? There. Okay. So let's replace x squared with u minus 9. U minus 9. Okay. Good. Now this half is being written here because it's a constant. It's a constant, and we don't bother ourselves integrating what? Constant. So normally anytime you see them in calculations, we just bring it at the back of the integral sign so that we can work on the variables involved. We can work on the main ones. Okay, so here after replacing x squared, we have u minus 9 over um, square root of u du. Now this one, we can, since it's having one denominator, we can split it into like fractions. That is u over square root of u minus 9 over square root of u. When it's like that and you compute it, this is what you are going to get at the end of the day. So if we have gotten it in this form, there is nothing that should prevent us from changing it to the other form. Okay, so what you are going to do here is you're going to split it into what? Like fractions. That is u over square root of u minus 9 over square root of what? U. Good. Now remember, anytime um, a fraction is of this form and you split it into this form, remember, when you compute it, it should give you what? This form. I mean, when you compute it, I mean, when it is of this nature, it should give you what? This form. Why? Because now this denominator and this denominator are the same. So this one, there's no need to find what? LCM. So just write one of the denominators and then either add or subtract what? The numerators. Okay, and when we do that, it's the same thing as what? This one. So sometimes when it is given in this form, you can split it to this form so that you can what? Easily work on them. Okay, good. So u over square root of u minus 9 over square root of u du. Okay, here what we are going to do is that though we can split them. Yeah, what we are going to do is that we are going to split them into um, two different integrals. That is going to be integral u over square root of u du minus integral 9 over square root of u du. I'm doing it that way so that we can easily work on each of them to know how each of them is solved. Okay. If I choose to just integrate the whole of this simultaneously, you find it difficult. I mean, knowing how you got answer for maybe one of them, either this or maybe that. But when I split it and I integrate this one separately and also this one separately, you could see that whatever steps or whatever approach that I use to solve, maybe this one will be reflected and that of this one too will be what reflected, and then nothing to be what omitted, because here if I do directly here, there is likely or probability that I will make some calculations. Okay. Yeah, good. Remember I said we are going to split it. Okay, so after splitting it, we've got it integral u into bracket square root of u bracket close raised to the power minus 1 du. Don't worry, I'm going to explain that. Minus 9. Remember I said anytime we are dealing with constant, the constant is, just bring it at the back of the integral sign. Minus 9 integral bracket open square root of u bracket close raised to the power minus 1 du. Good. Here you could here it was u over square root of u. Yeah, u over square root of what? U. But when you come here, it has changed to u into bracket square root of u raised to the power minus 1. And it is so because of the negative index law of indices. Now, the negative index law of indices states that when you are having a fraction like 1 over a and you want to write it in the form of power and exponent, it is going to be a raised to the power minus 1, a raised to the power minus 1. Okay, so when you apply the law here, you could see that 1 over a, when you make comparison, you could see that the square root of u is replacing what? The a. So if you are rewriting this one in terms of a raised to the power minus 1, it's going to be square root of u raised to the power what? Minus 1. Okay, and I did it this way because here we are having u and also here we are having another u here, so there is something that we can do before we integrate. This place is also the same because when you choose to integrate directly 1 over square root of u here, remember I said you will make some calculations, but when I do it this way, you're going to see every workings or every step that is involved. Okay, so doing it this way is telling us that there's going to be some other steps that is going to be what? Shown. Okay, so as I was saying, here is this one can be written as this one because the negative index law of indices, and here to this one too, it looks like this one, so it can also be written as it should have been 9 multiplied by bracket open square root of u bracket close raised to the power minus 1. But remember we first had similar problem, and how I solved it was to bring the constant at the back of the integral. Okay, that is the half there, that is this half, and here too we are having the same problem. So why should we bother doing so? Because we have already learned how such problems are handled. So that is why I brought the 9 here directly. Okay. Now let's continue. Here, the value of the square root sign is what? Half. Half. So that half will multiply this one. That half will multiply this one. That will going to give us what? Minus half. So that is going to give us a minus half. And remember, u raised to the power minus half multiplied by u is an indices and the base are the same. You can see that the base of the minus half and the base of this, let's say the power of this one is what? 1 is, the power of the u is what? 1, and the base of the 1 is also u. So from the laws of indices, when the base are the same and it's multiplying, we just add what? The exponent or the powers. Okay, so here this one, the value of this one is going to be what? Half, and you multiply this half by this one. Okay, as I was saying, say the value of this one is what? Half. So that half will be multiplied by this, and that will give us what? Minus half. Minus half. And also this one, the same thing is applied here. The value is the same, half multiplied by this will give us what? Minus half. Now let's continue. U times u raised to the power minus half. You remember u dot u is the same as, don't be confused, is the same as u times u. In math, when you see dot, maybe 1.5, 2.5, here we are not dealing with decimals. We are not dealing with decimals. We are not dealing with decimals. So this dot here does not mean u point, u blah blah blah. No, this dot here is telling us that we are multiplying this. We are multiplying this. We are multiplying this. So anytime you see something like 2x dot x, it simply means that 2x times x. H dot k means that hk. Okay, so u dot u raised to the power minus half is telling us that u is being multiplied by u raised to the power minus half. Okay, and now when it happens like that, it becomes what? An indices. You see that all of them are having the same what? Base. So what you are going to do is to what? Add their powers. Add their powers. That is the law of what? Product. So okay, the power of this one is 1, and the power of this one is minus half. So here we are just going to write one of the base, since the base are the same, one of the base, and then we add the two powers together. So we are going to get u raised to the power 1 minus half, u raised to the power 1 minus half. Now when you come here, you only have what? 1 u here, and there's nothing else. Okay, so u raised to the power minus half, that one, you just maintain it. You just maintain this one and then work on this one, and whatever we get after adding the powers, then we integrate. And when we integrate this one, you just also integrate this one alongside. Okay, good. Now 1 minus half is the same thing as minus half plus 1. They are all the same. They are all the same. Half plus 1, or 1 minus half, will give us what? Okay, let's find out. 2 times this one will give us what? 2, and minus 1 plus 2 will give us what? 1. So when you add this one, we are going to get u is equal to u raised to the power 1 over 2. U raised to the power 1 over 2. Now, whatever workings that needs to be shown has been shown, or whatever workings that needs to, make our understanding clear how we are going to get answers to this one and that of this has been what shown. So I don't think you be thinking of how answers to these are what arrived. Okay, so here we don't have anything to work on it again before we integrate. We are done with everything. All that we are going to do is just what? Integrate it finally. Okay, so when you integrate this one, you raise to the power 1 over 2, the power rule. Okay, so with the power rule, you all know how it is being done. To integrate this you're just going to add 1 to this power, and then we divide the whole thing by half plus 1, half plus 1. Okay, the same thing is applied here. To integrate this, we're just going to add 1 to this power, and then we divide it by minus half plus 1, minus half plus 1. Mind you, at the end of the day, whatever answer that you get for this one, integral of this one will be multiplied by what? This 9. And whatever answer that we get at the end of the day after integrating the whole of this will also be multiplied by what? Minus half. Okay, good. I didn't omit this side because I said I want to show you everything. Okay, everything, including the cancellations and that is involved. So I'm just show you everything. Okay, so here, as I said, we are just going to add 1 to the power here, so that is half plus 1 here, and we divided the whole of this one by half plus 1. When you come here, the same thing is what? Apply. So that is going to be minus half plus 1 divided by minus half plus 1. And here, half plus 1 will give us, let's find out, 2 times this one will give us what? 2 plus 1, that is going to give us 3. The same thing will be applied here. That's also 2 times this plus this will give us what? 3. When you come here, minus half plus 1 will give us 2 by this. So minus 1 plus 2 will give us what? 1. The same thing apply here. So this one will give us half. This one also give us what? Half. Good. Now, here, these two here will just go and multiply u raised to the power 3 over 2. U raised to the power 3 over 2. Okay, the same thing apply here. This one will just go and multiply u raised to the power half. U raised to the power half. Okay, good. 2 over 3 bracket open, square root of u bracket close, raised to the power 3 minus 9 into bracket 2u bracket closed. Good. U raised to the power 3 over 2 can be written as square root of u raised to the power 3, because now 3 over 2 can be written as half times 3, and the value of that half is what? If since it's being written as index, that half is what? Representing the square root sign. That half is representing what? A square root sign. So that one can be written as square root of what? U raised to the power 3. Now, when we rewrite this one, it's just going to be the same thing as u raised to the power half times this what? 3 here. Okay, so that's just get confused. Now here, let's open the bracket. Let's open the bracket. Now when you open the bracket, you could see that this okay, let's first open the bracket for this one. You will not open that for this one. Let's first open for this one. Okay, let's first open for this one so that the cancellation that will involve when we multiply this one through will be what? Easy. When we do so, we're just going to encounter another fractions of which we have to go do other cancellation. It might confuse us. So let's make it simple. Let's first open this bracket. So to open this one, we multiply this by this, okay, and that will give us what? 18. That will give us what? 18. Yeah, here you can see that square root of u raised to the power 3 has been written as um, square root of u into bracket square root of u raised to the power 2 is just the same thing as that. Remember from the workings that we did, u dot blah blah blah, if you apply that one, you could see that is the same thing here. Now when we change this one, or since the base are even the same, square root of u, the power of this one is 1 and the power of this one is just the 2 here. So when you add them, you're just going to get the same thing as this. Okay, and when you change it to the previous one, that is u raised to the power blah blah blah, that is also going to give us u raised to the power what? 3 over 2. So this one is the same thing as what? This. Okay, now before we open the bracket, let's deal with this. Square root of u into bracket square root of u raised to the power 2. Now the value of this square root sign is what? Half, and that half multiplied by these two give us what? 1. So this square root sign and these two will be cancelled out and to be left with what? U. Okay, and when that u is multiplied by this, we are going to get 2 over 3 multiplied by u square root of what? U. This one is the same thing as this, also the same thing as what? This. Okay, so that don't just get confused. Okay, good. Here, now let's open our bracket. Now if you open our bracket, the cancellation that will come across will not be confusing as compared to this step. Okay, so now let's open our bracket. Now when you multiply, so when we multiply this half through this half times 2 over 3 u square root of u is going to give us these two and these two will cancel to give us what? 1 over 3 u times square root of what? U. And also this half, when it's being multiplied by 18 square root of u, that is going to give us what? 9. Half times 18 will give us what? 9. That is 2 goes into 18 how many times? 9. And 9 by 1 will give us what? 9. Okay, so one over 3 u square root of u minus 9 u. Okay, let's continue. Good. Now we are done with the integration. And remember, we move from the x word into the what? U word to help us solve our problem. Okay, now let me cite this example. If in Ghana here we are having some technical problem, I mean some let's say, yeah, let me say any some technical problem, and we were not able to find someone here to solve it, and we contact somebody outside the country to solve that problem for us. When that person enters this world and then he is able to solve the problem at the end of the day, it is not a place he is living. So if his work in that particular place is done, what does he have to do? Probably go back, right? All other factors are held constant, because somebody can choose to stay because of this. Yeah, somebody may choose to stay if the atmosphere or if the environment is liking to him, or if the environment is something that he like most, or the choice normally depends on. But generally, when the person is done, probably he will go back. Okay, so we entered this U world to help us solve our problem. At the end of the day, we are done with what? Our problem. So what do we have to do? We have to go back to the X world. Okay, so if you don't go back to the X world, then you leave your answer like this, you might lose some marks, because anytime you make substitution, the question wasn't stated in this way. So the substitution was just to help you, the student, to solve the problem. And you are done. You have to go back to what was given. Okay, so since we are done with the integral, we have to go back to the X world. And going back to the X world, the variables in our present world, remember we make substitution, we know what is going to replace them. So here you see I've written, but u is equal to x squared plus 9. Like I said, we are going back to what? X world. And going back to the x world after the integration, wherever that we see this u, we are going to replace it with x squared plus 9. Okay, wherever we see this u after the integration, not before the integration. I'm saying this because somebody may you know misinterpret it, and during where he is integrating it, or where he's working on the integral, say, okay, well, let me just go replay this one there. If you go and replay this one there, you are just increasing your problem of solving the question. You're just going back to the x word, and also partial in the x word, and also partial in the u word. So it will be very difficult for you. I said after the integration, wherever you see this u, you just replace with it x squared plus 9, x squared plus 9. Okay, good. Remember the answer that we had to the other one was 1 over 3 u multiplied by square root of u minus 9 square root of u. Forget about the square root sign. What we are interested in here is what? Our u. So this is our u, and we know that our u in the x world was equal to x squared plus 9. So when I come here, wherever I see u, I just put the x squared plus 9 there. I don't care about whatever sign, whatever is being there. All I care about is u. Wherever that u is, I just put x squared plus 9 there. Okay, so here it was u multiplied by square root of u. Replacing it to x squared plus 9 is going to give us x squared plus 9 multiplied by square root of x squared plus 9. The same thing is here. 9 multiplied by square root of x squared plus 9. Okay, so now that we have entered the x word, the answer to the integral question is actually 1 over 3 multiplied by, into bracket, x squared plus 9 multiplied by square root of x squared plus 9 minus 9 into minus 9 multiplied by square root of what? X squared plus 9. So this is the answer to the integral question which is the answer to the what? The integral question we are just solving. Okay, so let's end everything. Let's end everything. You know, in maths, when you get your final answer, at time most somebody say, hence, therefore, it signifies that you are done with everything. And integration, when you get your final answer, it does not mean you are done. Remember, when you differentiate this, you are going to get that. But who knows? The question might be having some constants, some numbers that were what attached. So with integration, we normally put in our mind that there was some number. This is the question. When we differentiate this question, or when you differentiate this answer, it should give you what? The x cubed over square root of x squared plus 9. Now we normally bear in mind that when this answer was differentiating, or when this answer was differentiated, there was some particular constant that was attached to it. So if you are done integrating, since we don't know that constant, all that we are going to do is that we will just bring something to represent that constant, and which is what? C. And most of the times you can choose to use any variable at all, but normally what we normally use in math is, like, let's say C, or let's say K. Yeah, it depends on whatever you're going to do. You can even choose to write plus M. Nobody cares, it's just your constant. Okay, but generally what we use is what? C, representing constant. Okay, so now let's end everything. Integral x cubed divided by square root of x squared plus 9 dx is now equal to 1 over 3 into bracket x squared plus 9 multiplied by square root of x squared plus 9 minus 9 multiplied by square root of what? X squared plus 9 plus c. This c, as I said, is telling us that we are completely done with the integration. If you don't bring this c, you are not done with the integration. You will lose some marks. You lose some, some teachers, when you reach here and you leave your answer like this, I don't know how they do their marking scheme. You just give you some marks here, and the final mark to that question will also be given here. So when you reach here and you stop, you are not done. You get this mark, or you get this mark and you lose this one. Some teachers may also even, in their marking scheme here, they will not give you any marks at all, because sometimes though the students, we are, lazy. So the moment we get the answer, we become so happy that we forget to bring this one. So here they will not give you anything at all. And if here the mark supposed to be, let's say 2, and here supposed to be, let's say 3, which is 5, he will just omit this one. He will not give you anything here. And when you write your answer that therefore this one is equal to this plus c, you just write the whole 5 there. Yeah, you just write the whole. Some teachers, where they are mafias too, they will mafia you. It's not easy. Okay, guys, so the answer to the integral that we just solved is what? 1 over 3 x squared plus 9 bracket close multiplied by square root of x squared plus 9 minus 9 multiplied by square root of x squared plus 9 plus c. Okay, now you remember I said when you differentiate this, it should give you what? This, because of what? This constant. So remember I said when this answer was differentiated, there was some, we assume that there was some constant that was attached to it. So with this one was differentiated along with what the constant, and we gave this answer, and we are to integrate this, and after the integration we had this plus c. Okay, so what I'm going to do in my next video is that I want to prove to you that after integration, whatever you get when you differentiate it, it should give you the original question you integrated. Okay, I'm doing that because of the constant. As I said, that we assume that there was a constant that was attached to it. Okay, so I'm just going to, in my next video, I'm just going to differentiate this answer that I have to this integral question. I'm just going to differentiate the whole of this, including the c. Okay, so I'm just going to differentiate this one to find out if you'll be able to get this what question here. Okay, so in my next video, that's what I'm going to do. I'm just going to differentiate this answer to find out if I'll get what this one. If I do so and I get it, it means that I confirm what I said. Okay, all right, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. And those of you who be having questions, make sure you drop them in the comment section below. Okay, all right, thanks for watching.